Welcome to section 6.1, multiplying and simplifying rational expressions. Now we're going to have two parts, the multiplying part and the simplifying part. First, we're going to focus on the simplifying rational expressions. Now, we're going to simplify for two reasons. Factor into parts, meaning that you're going to have a polynomial or a trinomial, a term on the top of a fraction and on the bottom of a fraction. You're going to simplify, basically factor into simple parts. After you simplify or factor into simple parts, you're going to divide common factors. So it's when you cross out common factors and divide into one, making it into a simpler fraction or a simpler term. Factors can be either a number, variable, or binomial, and you will see from the following examples. In our first example, we have a fraction, and the numerator it's 10n plus 30, and our denominator 5n squared plus 9n minus 18. So what you're going to do is use the skills, the methods, the process that you learned in the previous chapter, chapter 5, factor by grouping, factor by GCF, and factoring trinomials. So let's focus on the numerator first. In the numerator, we have 10n plus 30. Here, we're going to factor by GCF. Now, what's in common between 10n and 30 is both of them are divisible by 10. So if I were to divide by 10, which is my common factor, so 10 will be on the outside. 10n divided by 10 will simply be 1n, or just n, and then positive 30 divided by 10 will be plus 3. So here are my two factors, the 10 that's outside, which was the common factor, or also known as the greatest common factor, GCF, and then my binomial, n plus 3. So that would be on the top. Now let's focus on 5n squared plus 9n minus 18. So that's a trinomial. Basically, we're going to factor using the x table. So let me identify, or let me write right here, 5n squared plus 9n minus 18. So identify ABC. 5, positive 9, and negative 18. So then this is where we do the x table. So the top is a times c. So we're going to do 5 times negative 18, which will be negative 90. And then our b value is positive 9. Alright, so you gotta factor out negative 90. So you gotta think of factors that can go in negative 90, but the sum of factors is positive 9. So you can do, for example, say we do positive 10 times negative 9. So it will multiply into negative 90, and then the sum and difference of the factors is just positive 1. Now, I'm not writing everything that we covered in the previous chapter, because you should be familiar on the process. Now, I could do, let's see, if I do 2, half of negative 90 would be negative 45. Now, the sum and difference between these two factors would be negative 43. So I can't do that. Now, I know that 90 is divisible by 15, so let's try 15. So 15 times negative 6. So when I multiply these two, 15 times negative 6 will also be negative 90. If I were to combine 15 and negative 6, the sum and difference would be 9. So my factors are 15 and negative 6. So it would be n, because we start with n, plus 15 times n minus 6. Now don't forget, my a value was not 1, so I gotta divide by 5. So my new factors are n plus 3 and 5n minus 6. Alright, those are my two factors for the denominator. So what I'm going to do is I'm going to bring back this pair of factors and this pair of factor back into the fraction. So my numerator is 10 times n plus 3 over n plus 3 times 5n minus 6. Alright, so from there, I'm going to divide my common factors. In this example, n plus 3 on the numerator and n plus 3 in the denominator. I'm going to divide them, meaning I'm going to cross them out. So what's going to happen is it's going to be 10 times 1 over 1 times 5n minus 6. The 1 came from when I divide n plus 3 from the numerator and denominator, and it became 1. So basically it would simplify. 10 times 1 is just 10 in the numerator, and then 1 times 5n minus 6. If it's just a single binomial, then you can write it without parentheses. And then that will be my final answer when simplifying this rational expression. So to review, in this example, in the numerator, I factor by greatest common factor GCF. 10 was in common between these two terms, so my common factor was outside, and inside the parentheses was the binomial n plus 3. In the denominator, I factored the trinomial here, shorthand, and then figure out that the factors are 15 and negative 6. Put in factor form. Now I realized my a was not positive 1, so I had to divide both factors by a. So I got n plus 3. This one I couldn't divide, so I moved the 5 in front of n, so we got 5n minus 6. Then I bring the two pair factors back into the fraction. I divide or cross out the common factors. They divide into 1, that's why I have 1s here. So basically I did 10 times 1 on the top, which is 10. 1 times 5n minus 6, which is just simply 5n minus 6. And that is our final answer. In this example, we have in the numerator 5r squared minus 5. And the denominator 2r squared plus 9r plus 7. Alright, so one step at a time. Let's talk about the numerator. 5r squared minus 5. Now my GCF, my greatest common factor, is both are divisible by 5. So 5 on the outside, r squared minus 1. Now what I noticed that the r squared minus 1 is the difference of square. So if I were to employ the method to factor a difference of square, what I'm going to actually have is I still have my common factor on the outside. My factors for r squared minus 1 will be r minus 1 times r plus 1. So I didn't write any much because I just basically employ the method for factoring difference of square in my head. Now if you are confused by that, then I would refer to the section 5.3, factoring perfect squares, and difference of squares. Alright, next one is 2r squared plus 9r plus 7. Alright, so A is 2, B is 9, and C is 7. All three are positive numbers. Again, I'm not going to write the whole thing. Basically, just follow the same process. So top A times C, 2 times 7, which is 14. And then my B is 9. Alright, so for positive 14, I would have to use 2 times 7. When I combine these two numbers, my sum and difference is 9. So my correct factors is 2 and 7. So I'm going to write R plus 2 and R plus 7. Now, I'm not done with that because my A value was not positive 1. So I got to divide by the A value, which is 2. So we're going to have R plus 1 and then 2R plus 7. Alright? Now, my group of factors from the numerator, right here. My pair of factors from the denominator, right here. We're going to bring it back into the fraction. So, 5 times R minus 1, and then R plus 1. Over R plus 1, and then 2R plus 7. Alright, now you're going to look for common factors that you can divide from the numerator and from the denominator. So basically, what can you divide from the top and from the bottom? In this case, the R plus 1. So I'm going to cross them out, basically dividing them into 1. So when I divide into 1, what I'm going to actually have left is 5 times R minus 1 over 2R plus 7. So that would be my simplified answer for that example. And let me box that up. Now, I didn't write the 1 just like how I did in the last example, because simply, if I were to multiply the numerator by 1, I would just have the same thing that's what I have right now. So for example, 5 times R minus 1 times 1, I'm just going to get the same thing. Then 2R plus 7, the whole thing times 1, I'm still going to get the same thing. So unlike the last example, I just didn't write the 1 here. But the process is the same. I just basically did a faster way, just skipping by that process. So again, this is our final answer, 5 times R minus 1 over 2R plus 7.